Welcome to the RadiantWeb tool demonstration. RadiantWeb is a semantic annotation tool for annotating web services. Annotating a web service is the same as annotating the description document for the web service with concepts from the ontology. The description document, commonly known as the WSDL document, describes the web service in terms of operations and its inputs and outputs and bindings. As you can see, the tool has two panels, the WSDL viewer and the ontology viewer. The WSDL viewer is used to load the WSDL document that the users want to annotate, and the ontology viewer loads the ontology used for annotating the WSDL document. Now let's start by loading an ontology. I select the ontology for biomedical investigations, which is an enriched version of the OBI with the terms for the bioinformatics domain. Now click on the Load OWL button to load the ontology. Now let's load a WSDL document. Here I selected a WSDL from the WooBlast web service. The WooBlast web service is a bioinformatics web service to perform pairwise sequence alignment using the BLAST algorithm. The WSDL is loaded as a tree structure. To make it easy for the user, we trimmed the complex structure of the WSDL and displayed it as a tree structure of operations and its inputs and outputs. If you want to see the exact XML view of the WSDL, you can click on the WSDL XML View button on the top and see the XML view of the WSDL with all the types, port types, and operations. Now let's get back to the tree view by clicking on the WSDL Tree View button. The documentation for the entire WSDL, which describes the functionality of the web service, is shown in this box. The WSDL is displayed as a tree structure at different levels. Level 1 has all the operations of the WSDL. Open the operation. In the next level, you will find the input and output messages. Further opening the level shows the different inputs of the operation. All the levels of the tree are color-coded. The color codes are explained in the legend at the bottom. The elements are also provided with tooltips, which give some information about the element. For instance, when you mouse over on Email element, the tooltip is User Email Address, which is very obvious. But if you look at another element, like EXP, its meaning is not intuitive and the user cannot understand what it means. The tooltip provided for EXP is Expectation Value Threshold, and a more detailed explanation is given. This information helps the user to understand what EXP means and helps the user find the correct annotation. Now let's look at the ontology. The ontology is loaded as a class hierarchy of the concepts. The definition panel displays the definition of the selected term in the ontology. I click on DNA sequencing service. It is selected and its definition is displayed in the definition panel. This will help the user in deciding whether this particular term can be used for annotation. The tool provides a provision for searching the ontology. Enter the query string that needs to be searched in the text box and click the search icon. Let's search for the term sequence in the ontology. The results are displayed as a ranked list with its label and definition. If you are interested in knowing where the term is placed in the hierarchy of the ontology, double-click on it. It will open the particular term in the ontology along with its definition. Now let's start the annotation process. Annotation can be done in two ways: manual annotation and semi-automated annotation. Manual annotation involves searching for the term in the ontology and dragging and dropping it on the element of the WSDL. Let's say the user wants to annotate the element EXP in the WSDL. The user has to manually search for the concept in the ontology by browsing through the ontology, but it's highly impractical that he would know the entire ontology. So, now the user can use the search facility provided by this tool. I will do a mouse over to get the tooltip, and the tooltip says expectation value. I enter expectation value in the text box and hit search. The results are displayed in a dialog box. Here you can see expectation value at the top, which is our required concept. I double-click on it and it is opened in the ontology viewer. I can drag this expectation value term from the ontology viewer onto the EXP in the WSDL viewer and drop it. The element is annotated. The green color for the annotation signifies that it is finalized and approved as an annotation, as the user has added it. If you want to check whether the annotation is actually added to the WSDL, you can do it with the WSDL XML View button. We search for EXP, and we can see that the attribute has been added in a different color to the element EXP. This is the annotation and has the URI of the concept that we select as the value for annotation. Switching back to the tree view, now if you feel that the annotation is not correct, you can remove the annotation by clicking the close icon before the annotation. This will remove the annotation. Doing this entire process of searching the ontology and then dragging and dropping for all the elements in the WSDL is definitely very tedious and hard. To speed up the process, the tool provides semi-automated annotation. In semi-automated annotation, the recommended terms button is available for each and every element or for the entire WSDL. Let's check the option of recommending terms for each and every element. As an example, I try to annotate program. Now I click the recommend terms on the program element. The ontology is searched for the appropriate terms and the results are displayed as a ranked list in a dialog box. Here, BLAST algorithm is the correct annotation and is the top ranked candidate. Now I select this term and click on Annotate and the WSDL will be annotated. If you want the cross-check the annotation, you can click on the annotation and the term will open in the ontology and its definition will be displayed. As you can see, this option has speeded up the annotation process, but the user has to still get the recommendation for each and every element. Now the user can use the option of recommending terms for the entire WSDL. The Recommend Terms button at the top provides this option. I click on it and the WSDL will be loaded with the recommended terms. The recommended terms are shown in red, suggesting that the user has to approve the term for annotation. Here, email address is recommended for email. It's the correct term, so I will just approve the term by clicking on the tick icon at the beginning of the recommended term. Now the term turns green, indicating that the term is approved for annotation and is added to the WSDL. The recommended terms, which are in red, are not added to the WSDL until they are approved. Let's go ahead and approve some of the terms. Now let's check the next term, program. It suggested BLAST algorithm. As it is already annotated, the annotation can be rejected. I reject the term by clicking on the close icon next to the approve icon. Now let's try to look into element EXP. Before approving, we can cross-check if the recommendation is correct. By clicking on the recommended term, the term will be opened in the ontology and its definition is displayed. Now we can compare the definition here with the documentation for the element we get from the tooltip. Here the recommended term is correct, so I will go ahead and approve the term for annotation. I will not go and approve all the terms, but let me just move to the outputs here. The recommended term is Web Service Execution Identifier. Let's verify if this is the correct term. Looking at the definition for both, this is the correct term, so we approve it. Now check for an operation. Get Status. The recommended term is Check Job Status Objective, and it is the correct term. We approve the term. The recommendation is purely based on string similarity metrics, so the WSDL should be well documented with meaningful definitions. Failing to do this might result in wrong recommendations. For example, if we check the recommended term for the operation run, it gives Check Job Status Objective. If we check this definition, it is not the correct term. Here the documentation for run says Submit a job for analysis. It is very vague and does not specify about submitting a job for pairwise sequence alignment or BLAST. The operation name run is also very vague, so the result is a wrong recommendation for the term. We reject the recommended term for run. Now we can click on the Recommend Terms button on Run. The results are displayed and the sequence alignment objective for the results looks closely related. I select the term and click Annotate. The annotation is added and I click on it and open it in the ontology. Now opening Sequence Alignment Objective will open the subclasses that are Pairwise Sequence Alignment Objective, Multiple Sequence Alignment Objective, and Global Multiple Sequence Alignment Objective. Opening Pairwise Sequence Alignment Objective gives local pairwise and global pairwise sequence alignment. Our required term is local pairwise sequence alignment, and I drag and drop the term onto Run. Run is annotated with local pairwise sequence alignment. Now I remove the annotation Sequence Alignment Objective. You can check the WSDL by looking at the WSDL XML view provided by the tool. Thus, the annotation process has been made quicker by providing recommendations. After annotating the elements of WSDL, you need the output that is the annotated document. You can get this by clicking on the Save WSDL button at the top, and the WSDL document is saved to an XML database, ExistDB. Now I will go to the ExistDB database. I will have to open ExistDB application in my browser, and then I have to go to Admin. In Admin, the XML documents are under the Browse Collections option. Once I click on it, it will open all the collections available here. Here our collection is the RadiantWeb, so I open it and you can see the WooBlast WSDL file. I open the WSDL file. Now searching for annotations, you can see that the annotations are present. Thank you for watching this tutorial.